All right, let's dive right into this explainer and embark on a massive cosmic journey. We are going all the way from the absolute beginning of everything right to the very end of time. It's honestly the greatest story ever told. Today, we're going to break down this monumental timeline step by step, and we'll be using Notebook LM to help us synthesize all the deep physics and cosmology that actually govern our reality.
So, what actually happened before the Big Bang? It's the ultimate mystery, right? It kicks off our entire timeline, and it challenges us to rewind the clock a staggering 13.8 billion years into deep time. It's one of those questions that completely bends the mind, and it's puzzled physicists and philosophers for generations. To really trace the incredible physical cosmology of our universe, we first have to try and wrap our heads around the absolute zero point of history.
That brings us to Section 1, the ultimate beginning.
Listen, we've got to clear up a massive misconception right out of the gate here. The Big Bang was not a bomb going off. It was actually the rapid, sudden expansion of the universe itself. A lot of people naturally picture this giant explosion happening inside some pre-existing dark, empty room. But that is fundamentally incorrect. There was no room. There was no space. There wasn't even time as we understand it. Everything began from this incredibly dense, fiercely hot point, a singularity, where space itself simply began to stretch outward, literally carrying everything with it.
Moving on to Section 2, matter versus antimatter. Picture this. At the very dawn of time, matter and antimatter were locked in this constant, brutal cycle of mutual destruction. In those earliest stages, right after that initial expansion, the universe was just a chaotic soup containing equal amounts of both. And the absolutely fascinating and chaotic thing here is that whenever a particle of matter meets its antimatter twin, they instantly collide and completely cancel each other out in a brilliant flash of pure energy. But wait a second, if they continually destroy each other, why is there anything here at all? Like, why aren't we just floating in a formless void of pure energy right now? Well, it's because a super slight imbalance eventually allowed matter to survive. After thousands of years of this extreme cosmic demolition derby, a tiny, tiny fraction of regular matter actually outlasted the Great Annihilation. And that seemingly insignificant leftover matter, that is the foundational building block for literally everything we see today. The galaxies, the stars, the planets, and eventually you and me.
Which brings us to Section 3, echoes of the Bang.
Now, since we obviously can't just hop in a time machine and travel back 13.8 billion years, scientists have to act like cosmic detectives. They use key observational clues to construct the Big Bang model. First up, we have redshift and Hubble's law. These tell us that when we look out into deep space, galaxies are actively moving away from us. If you hit rewind on that expansion, well, everything must have started much closer together. We also look at the abundance of specific light elements, things like hydrogen and helium, which were forged in the immense heat right after the Big Bang. But honestly, our absolute most spectacular piece of evidence is the cosmic microwave background. Think of it kind of like the universe's oldest baby picture. After the universe expanded and cooled down just enough for the first atoms to form, light was finally able to travel freely. This produced a massive flash of radiation that still fills the entire universe today. It is the literal residual heat from the creation of everything, and it perfectly confirms our models of the early universe.
Next up, Section 4, an expanding universe.
This timeline really puts our epic journey into a mind-boggling perspective. We start right at 0 years. That's the singularity, where space and time actually begin. Over those critical early thousands of years, matter wins that great war against antimatter, which sets the stage for structure to form. Fast forward past the formation of the first stars, the galaxies, our own solar system, and that brings us to 13.8 billion years, which is exactly where we sit today. Over this vast stretch, the universe hasn't just been sitting there static. It has been continuously expanding and cooling down, which is what allowed complex chemistry and life to take hold in the first place. Now, to map all of this out precisely, physicists don't just guess. They rely on very specific mathematical models. Equations like Friedmann and the lambda-CDM model aren't just complex academic buzzwords. They are the absolute bedrock of physical cosmology. The lambda-CDM model, for instance, factors in dark matter and dark energy. Those are the mysterious, unseen forces that are actively driving the accelerated expansion of our cosmos today. Together, these equations describe exactly how space, time, and gravity all interact to stretch the fabric of reality on a massive scale.
And finally, Section 5, the ultimate fate.
Okay, so we've mapped out our origins. We know our present state, but what on earth does the future hold? Well, if we continue to expand according to our current models, the universe will eventually grow colder, darker, and emptier. Stars are going to burn out,
black holes will evaporate, and everything will seemingly just fade away. But does it really just stay a cold, dark void forever? Okay, get ready for this number. 10 to the power of 10 to the power of 10 to the power of 56. It is almost impossible for the human brain to comprehend a number this ridiculously large. Just to put it in perspective, our current universe is only 13.8 billion years old. According to theoretical physicists, this staggering number represents the immense scale of time it might take for quantum fluctuations in a dead, empty universe to trigger another universe to just randomly appear after ours ends. It suggests that even an empty void isn't truly empty, provided you wait long enough.
So that leaves us with a pretty wild question. Is the absolute end of time just another Big Bang waiting to happen? Will our universe's end be the spark for a brand new beginning? If another universe can simply spark into existence out of the void after an unfathomable amount of time, perhaps our 13.8 billion year history is just one fleeting chapter in an endless, repeating, cosmic book. What do you think happens when the clock finally runs out? Thanks for joining us on this explainer, and keep looking up.